Now, after all, we will know how many types of hybridizations are there and what are their geometries. In case of hybridization, there is SP, SP2, SP3, SP3D, SP3D2, SP3D3. Okay. These are 1, 2, 3, 4, 5, 6. These are the 6 types of hybridization that you will see in a covalent molecule. Okay. If we are considering about covalency in metal complexes, then some more hybridization will be there and we will discuss it a little bit later, because I have already told you that in chemistry there are 4 pillars: stoichiometry, atomic structure, periodic table and chemical bonding. We are talking about chemical bonding. Why 4 pillars? Because if we know all the 4 chapters, these are the basics. If you know these 4 chapters very clearly, if you have the whole concept of these 4 chapters, then nothing can stop you from understanding chemistry. The chemistry subject is full of logic. You just need to clarify your basics and nothing else. So these are the 6 hybridizations. So their geometries, what will be their geometries? This one will be linear, this one will be trigonal, planar, okay, and this one will be tetrahedral, okay, and sp3d, it will be trigonal, bipyramidal, okay. Now sp3d2, it will have octahedral, okay, and sp3d3, it has 2 types: capped octahedron or pentagonal bipyramidal. Capped octahedron, okay, or pentagonal bipyramidal. Okay, so these are the geometries, but hybridization has been done, geometries has been done. One more thing is there. What? Shape. Geometry and shape, are they different? Yes, they are different. If I have to give you an example, can you tell me what is the taste of a rasgulla? Sweet. Then what will be the taste of kalakand? Sweet. Okay, you are telling about rashalu, means it will have some soup in it, sweet soup. Then what will be of rabdi? It also has some sweet soup. So how to know the taste of the rasgulla? You need to eat it. You need to eat one in order to understand the taste. You cannot tell about the taste. You can tell that, oh, it tastes really good. But how, you cannot explain. Because you have to feel it by yourself. This subject is like that only. You have to feel it to understand it by yourself. I can show you the way, but you have to know how to feel it. Okay? Now, the shape. Linear will have a linear shape. Trigonal, pyramidal may have a bent shape or a V shape. Why? I have told you again that we cannot see the lone pair. In geometry or hybridization, we are considering the lone pair. In hybridization, we are considering the lone pair. That is why geometry comes like that. But in actual shape, we cannot see the lone pair, but we can see its effects. We cannot see the lone pair, but we can see its effects. What type of effects? It will decrease the bond angle. It will increase some strain and decrease the bond angle. So these are the things. Now tetrahedral, the shape will be tetrahedral. It can be also trigonal planar. Okay, trigonal planar, bent or V. tetrahedral, it can be tetrahedral, then pyramidal, okay, then bent. Trigonal bipyramidal, it will have trigonal bipyramidal shape. It can have a seesaw shape, okay, and then what it can have, and again it can also give a pyramidal shape also, okay. So all these are possibilities. It can give a T-shaped structure. These are all possibilities in sp3d2. In sp3d2, octahedral, then square pyramidal, okay, then square planar, like that. Capped octahedral, you can see. So this difference in shape, the difference in shape from the geometry comes because of only one thing. What? Don't know. See, I am giving you an example here about bend. Example, water. 2 bond pair and 2 lone pair. So it will have a bent shape. Okay. This angle, tetrahedral angle, is 109 degree 28 minutes. It will reduce to nearly 105 degree. Okay, so it will have a bent shape. Now pyramidal, we have already discussed earlier about NH3, 107 degree, or NF3, 102 degree. Here TBP, seesaw or T-shaped. In TBP structure you can have anything, okay, but in seesaw SF4, seesaw shape. How? This is trigonal bipyramidal structure, and this one will be occupied by lone pair, and all this by floating. So it will have a seesaw shape. Here CLF3. In CLF3 it will have shape like this, a T-shaped structure. Just like that, sp3d2 and square pyramidal and square planar. You can take the example of XE05, XE1, 2, 3, 4. XE04 is a square planar shape, but it is a tetrahedral structure. You cannot take this example here. You can take the example of XeF4O. This is the example that you can take here, or XeF4. Okay, this type of examples you can take. And in case of this one, IF7 is a great example of pentagonal bipyramidal. Okay, so this is the factors that you need to know. One more factor is bond angle, 180 degree, 120 degree, 109 degree, 28 minutes. This is one part will be 90 degree, another part will be 120 degrees. Okay, here again 90 degrees, and here you are getting 90 degree, 90 degree, 90 degree, and the lone pair also have 90 degree to the square planar base. Next, IF7 also will be like that, but in here there will be a pentagon, and the distance will be 360 divided by 5, and that is how you will be able to find out. Okay, so these are the basic factors that you need to know